Hello, everyone. Cecilia from ISSIP here. So we have a guest from Australia today, Aditya Ghose. Hi, Aditya. Thanks for joining us today. Lovely to have you here.
Likewise, good. I'm very glad that we are getting a chance to chat.
Yeah. Could you introduce yourself to the ISSIP community?
Sure. So my name is Aditya Ghose. I am a professor of computer science at the University of Wollongong. I had a research lab called the Decision Systems Lab. I've done that for the last 24 years. And we do some interesting work in the interesting applications of AI in service science. I also head a body called the Service Science Society of Australia. I have had continuing contact with ISSIP since its inception, and I serve as its ambassador, I guess, in these parts.
This is amazing to know. Yeah, that's great to know that ISSIP's footprint is in Australia as well. Yeah. I know that you're doing amazingly interesting work around digital twin technology, and that is application to healthcare setting as well. Could you just share a little bit more about that with us?
Certainly. Digital twin technology, I think, is particularly interesting. And we are trying to build the technological infrastructure to make these things more accessible. So we're working on trying to learn digital twins from observing the behavior of the entity that we are going to twin. So that's one of the ways in which you can build digital twins on a industrial scale, if you will. So you're not limited by the constraints of handcrafting these things. So that's part of our work. There's also very interesting fundamental formal questions around digital twins that you have to answer, questions around what kinds of properties do you want a digital twin to satisfy, what kinds of connections should there be between a digital twin and the entity that is being twinned. So one of the things we are working on is the idea of digital twins of organizations, and that leads us to very interesting territory. I mean, so understanding to create a digital twin of an organization requires, if you will, the depth of understanding that most people don't plumb, right? So it's a really interesting question. It takes us on a journey that connects computer science with management thinking in many different ways.
Absolutely.
Something I've been very interested in for about a decade and a half. The idea, and I often call it algorithmic management, but the idea is that there is a very interesting intersection between management thinking and computing thinking that has yet to be explored. So digital twins is something we find very useful. And now, if you think about the healthcare sector, one of the biggest problems I'm sure you would see it in the UK and the NHS and also in many other parts of the world, is the problem of healthcare resource management, right? So
definitely, yeah.
Yeah, absolutely. So there you have to worry about these things, right? You have to worry about, number one, of course, the overriding objective is improving patient outcomes. So that comes first. But as a secondary objective, you also want to better utilize the available resources, because in a roundabout way, that also contributes to improving patient outcomes. So we're working on that problem. So what would be the right way to if you will, the management constructs for healthcare systems and the optimal ways of utilizing healthcare resources, the optimal choices of when to prescribe a certain when to suggest a certain medical procedure, when to suggest a certain kind of test. These are all things that ultimately load the healthcare system, and you need to do it right. You need to do it when it's really necessary, when it gives you the right outcomes, do it at the right time, not overload the system.
Definitely. Yeah.
Even talk about, yeah, that's right. So even load balance across systems. So one of the small projects we once did was to build a distributed optimization tool that would allow capacity handover between three hospitals as far as their radiotherapy infrastructure was concerned. So linear accelerators, which you would use to provide radiation treatment. So there are certain hospitals which are overloaded with demand and certain others which are less loaded. And they are probably not in, they're in reasonably close physical proximity, so you can use the resources of one to service patients in the catchment area of the other. So we built a system which would allow us to do this. So this was, the southern suburbs of Sydney and Wollongong, which are in very close proximity to each other. So you could as well go to the one hospital or the other hospital without breaking too much of a sweat. So that's, yeah. So that was a little example of the kind of thing you could be doing, but this has to be done on a mass scale, right? So you have to really do this in an all-pervasive fashion everywhere. And again, what we're talking about is building digital twins and ultimately decision automation, decision support, technology. Again, when you say these things, people worry, are we taking the human out of the loop? We absolutely aren't, right? We are simply providing additional help to the human to understand how to solve these problems. So the overarching principle is we are providing decision support in the 1960s sense of the term, which has not changed, right? Which is that we want to help humans take better decisions, but also automation, because in many cases we don't want to even bother the human with routine decisions, where it's perfectly okay to let the machinery take the decisions because the machinery is almost never wrong for that class of decisions. So there can be such situations. So we want to talk about those, but ultimately we also want to talk about, so there's been a term that's had some currency in AI, which is called adjustable autonomy, which is this idea that you build a AI system where the amount of autonomy you're going to permit the system can be adjusted on demand, on the basis of the context, on the basis of the problem, and so on and so forth. But here we're talking not so much about just the autonomy aspect, but the overarching principle of human machine teaming, right? What is the, right? So how do they work together?
Exactly.
Now, the people who look at it mostly these days, curiously, are people who are into building defense technology, autonomous weapon systems and so on. They talk most about these things, but these concepts are equally applicable in healthcare and in many other places. So so the idea that I find intriguing is the idea of adjustable teaming. So how I would interoperate with the machine should be context dependent, dynamic, defined in real time, responsive to whatever is happening in the context.
That's very interesting, Aditya. So it sounds more like augmenting human intelligence, right? Rather than overtaking the human intelligence. So
Correct.
Yeah, great. Awesome. And also, if there's any special project that you would like to share with the ISSIP community, you're more than welcome to do so. Any interesting project that you're working on lately in service innovation?
Yeah, so we are doing quite a bit. I'm trying to go through the landscape of the various projects we do to pick the one that might be most interesting. But yeah, one of the, I mentioned a few, right? So the one is the idea of learning digital twins by observing the behavior of the thing that you're building a twin for, right? So that's one of those interesting projects. We've also, we do a fair bit of work in the national security domain, where some of these teaming aspects that I mentioned show up quite a bit. We work very closely with our local hospital in doing these things. So digital twins, being applied to the healthcare setting would be one. A lot of what we do could be classified under that heading. And we've had a long history of working with some of the larger IT companies. So IBM Research, Bosch, Xerox Research, and so on. We've done work with all of these entities on problems such as process mining, which is learning business process models from data, things of that sort. So we've had a very interesting run of doing those kinds of things. These days, there's a lot of interesting applications of AI in cybersecurity. So using AI in detecting vulnerability, assessing risk, real-time responses to cyber attacks, all of those things.
Definitely.
That we're looking at, yeah.
Definitely, because as more people are working from home, and still, even after the pandemic, like the hybrid workforce, it's going to stay there, right? So I'm definitely, like cybersecurity, just making sure that everything's safe. I think there is a huge demand for that. And then I've seen a lot of startups actually popping up in that space as well.
Exactly, and it's a very happening space because there's so many opportunities. Yeah,
exactly. So before we close this call, is there any final thoughts or suggestions or advice for the ISSIP leadership, ISSIP members, or as a community in general?
Yeah, these are almost suggestions to myself, because these are things I should be doing in the Australian context as much as ISSIP should be doing internationally. So in the Australian context, I think I know Jim Sporer from a while back. Now, Jim's idea of service science, I have always found very compelling. But fashions change and fashion trends change, and so I suspect that right now the term service science and all of the stuff that it entails is not hugely fashionable, but the challenge and the opportunity is to make it so, to remind our user community that service science is an enormously interesting, compelling notion, and that there are opportunities. Everything that we talked about so far fits very well under the umbrella of service science and service innovation and so on. So in that sense, I think that's the big challenge, to convince the user community that there is value here. And it's not just, we all make our bread and butter living out of doing machine learning and that kind of AI, but that's well known, and the opportunities for innovation are possibly, I might make many enemies by saying this, but probably lesser than if you said, my primary driver is service innovation, and from that perspective, I want to understand what I can learn, how I can use data, how I can provide decision automation, and so on and so on, right? So in that sense, there's real meat in service science, and we haven't even scratched the surface. So I think there's a lot left.
Sure, yeah. There's, definitely, there are like enormous opportunities and then a lot of more work to be done. And I absolutely agree with you. Yeah. Thank you so much for joining us, Aditya Ghose. And then I really enjoyed chatting with you, especially the digital twin technology. I'll definitely check out your papers. And hopefully, I get to meet you and once I'm back in Oceania at some point.
That's right.
Yep. Thanks for joining us. Thank you everyone for joining us as well. We hope to see you again.
Been a pleasure, Cecilia. Thanks, everyone.